Okay, if you have the yellow test and are wanting to do corrections, you are in the right place. If you have the blue version test, go find the other video. I made one just like this with the blue version test. It will help you more than this one probably. Okay, before I start doing the questions one by one, let's talk about test corrections papers and how to fill them out properly and use them correctly. Okay, read the instructions. Read the instructions. I could stop there, but I'm going to be a little more annoying and go through it in more detail. If you want, you can skip this part. Okay, first, for each question you missed, write a sentence explaining what you did wrong the first time. Then resolve, not resolve, resolve, I guess resolve could make sense, the problem, showing your work and all the details, so do it correctly. Sorry, here we go. Then write a sentence explaining your new solution. Do all three parts for every single question that you missed on your original test paper. Example, pretend this part right here at the top was on the yellow paper. And this was the question, solve that equation, and I did it wrong. I got x equals 9. That was not correct. So I got a big X on my paper. Pretend this is on the yellow paper. Then you're going to say, oh, I need to do test corrections. And on your test corrections paper, this that looks like this, you're going to do this. First is this part, a sentence explaining what you did wrong the first time. I forgot to divide the 6 by 3. Okay, that's why I messed up here. B, redo it. So instead of the way I did it the first time, I'm fixing everything, doing it correctly, showing all the steps and work, and getting the answer. Don't just show the work, but not write the final step. People have done that before. And don't just write the answer and not write the work. That's silliness. You're not going to get credit if you do either of those. Okay, part C, very important. Write one sentence explaining your new solution. For this one, I wrote, I divided the whole left side of the equation and the whole right side of the equation by 3, then simplified to get x. You're explaining what you did on this part right here. How, why, what of this part right here. Okay, don't forget to do part C. By the way, really quick, what if you didn't even try on number 4 because you blanked or you just didn't know it, and on the test you left this problem blank? Well, on part A, just say, I didn't do it. Okay? But part C, you still have to give a full explanation of what you did do here. Okay? So you should have all three parts for every question. Even if you left it blank, then part A will be, I didn't do it. But part C and part B should still be all this stuff. Okay? It's not super long. One sentence, doing what you should have done for part B. That's it. Except staple this to the front of your test paper when you're done. Staple them together. Don't just turn into white paper. Okay, enough of that. Let's get to business. Here we go. If it's exponential in the instructions, it says up there, change it to logarithmic. What's the base? The base is the x. What's the power? The 18. Actually, I'm going to pause and pretend that I forget totally how to do this. Oh my gosh, I don't know what's going on. I don't know which part is which when you go to the log. Skip that problem for one moment. Let's go to number 2. It's a little bit easier to figure it out and make sure it makes sense and it works on number 2, then go back to number 1. So this one, it's starting in logarithmic form, which means according to the instructions, we need to go to exponential form. So the base is always that number, the little number 13 the number it equals to is always the power, and then the thing inside the log is your answer. Don't know where the 3 came from there. Adding 3's all over the place today. Okay, so 13 squared equals 169, and you can check your calculator. That indeed is true. You get these 3 numbers to exponential form, that's what it looks like. Now, I'll erase that so you can see the numbers a little better. You can use this problem with numbers that you can test and make sure how it works, and use it as a guide to help you with this one. Okay, this one, you're starting with exponential, so you're kind of going backwards. If it's exponential, you need to go to logarithmic. So this is kind of equivalent to that, and you need to figure out what logarithmic equation would be equivalent to this. So it's going to be log, it's going to have a base, it's going to have something here, and it's going to equal something. So using this one as a guide, the 2, which is the thing after the equal sign that's by itself, is the power, the exponent. What would that be equivalent to right here? So remember, this and this are the ones that are similar. The 2 is like the 18. So that is going to go right here. So the 18 is going to, that's the power. Let me kind of color code things here. The 2, that is equivalent to the 18 over here. The base, what's the base? It's all about that base. Oh my gosh. Okay, 13 is the 13. It's the thing with the power. So the thing down here should be the thing that has the power on it, which is the x. The x has the power of 18. The 13 has the power of 2. So this number here, and that number there, that number there, that number there. Okay, see how I'm using this one as a key and going backwards here. And then finally, the big number inside the log is the thing after the equal sign. So the thing after the equal sign should be the big thing in the log. So, and you can, hopefully that made sense doing it that way. But the number with the power on it, that's always the base of the log. The number that's equal to is inside the log, and the power is what the log equals to. Hopefully your flip chart notes helped you with that as well. 4 to what power is 64? That's what a log means. What power of this base gives me this number? 4 to the first is 4. 4 squared is 4 times 4, which is 16. 4 to the third is 16 times 4, which 6 times 4, 24. 4 times 1 is 4, 5, 6. It's 64. You could use your calculator. 4 times 4 times 4, 64. So 4 to the third power is 64. Hopefully that wasn't too fast for you, but calculator-wise, 4 times 4 times 4. See how many 4s you have to multiply, or what power of 4 you need to get 64, and it's 3. Number 4 is a little easier. 9 to what power is 81? 9 to the first, that's 9. 9 squared, that's 9 times 9, which is 81. So the answer is 2. There you go. That's what a log means. What power of this base gives me this thing? That's what a log means. Oh. Okay. Calculator. Well, let's do natural log first. That's really easy. Just use the LN button on your calculator to do the natural log and type in 3.3, and it will tell you 3.3 1.19. It says 3922468 39 is going to round. I need 3 decimals because it says the thousandth, 10th, 100th, 1000th place. So this is the last number. It's a 3, but it will round up to a 4 because it's 39. Hopefully that makes sense. Sorry, 1.194. Okay, this one, there's no log base 4 button. There's a natural log button, a log base E, which we just used over here, and there's a log base 10 button on your calculator, which just says log. So you got to use your change of base formula. If you have it in your flip chart, which you could use on the test, this was easy peasy for you. Log base 10 of 53. How do I change the base of that log? Well, it's equivalent if you just divide by log base 10 of the thing you want to change the base to, which is 4. Okay. You just had to know that from our assignments or from your flip chart notes. And type in your calculator, log button, 53, close parentheses, divided by log button, 4, close parentheses, equals 2.86. Again, it's a 39, so I'm going to round it up to a 4. There you go. So you look at all that for a second. We'll go to the next page. Okay. Use the natural log function on your calculator to help you solve each equation. Show all your work and steps. Round your final answers to the nearest thousandth. Okay. To get rid of e to a power, you need to use the natural log, but this -2 is in the way of getting that to work. So we're going to divide by -2 before we try to mess with any fancy stuff to get the e to the power by itself so we can do the natural log stuff. Okay, -2 divided by -2 is 1. So if you want 1 times 5 e to the 5p equals 15 divided by 2 is 7.5, or you could just leave it as 15 over 2, either way. Okay, now I'm going to get rid of the e to the power of something by doing the inverse operation. Log base e. So natural log will cancel e to the power and just leave what the power is. Hopefully that made sense and wasn't being as... Okay, natural log button on your calculator to get ln 7.5, that's 2.0149. Okay, to get p, that's 5 times p. To get rid of multiply and divide by 5. 5 divided by 5 is 1, so it's 1p. I'll just write p here. And use your calculator again here. Divide by 5. Get 0.40. It's 298, which I will round up to 3. Okay. Here we go again. We want to get the e to this power of stuff by itself before we go around lning things. Natural logging, I should say. So let's do that. That's nice and easy. Add 9 to both sides to get rid of a -9 on the left side. -4 plus 9 would be 5. Now we can say natural log of that equals natural log of this. This side we're going to plug it into a calculator. This left side, it's just going to leave us with 10x. Natural log and e to the power of something are inverse operations. Natural log of 5, type that in your calculator. It's 1.60943. 8. Okay, notice I'm going a little further than I need to till I get to my final answer. Then I'm rounding to the thousandth. Can better to go too much than to too little. Until we get to the very end, then we go exactly how much it told us. So divide by 10 to get rid of multiplying by 10. And x equals, you don't even need a calculator for that actually, 1609, we'll round up to a 1. Okay, there we go. That's number 8. Okay, number 9 and 10 is a little bit probably the more confusing part, but it tells you in the instructions exactly how to do it. So, will I cry for you? No, I won't cry for you this time. Show your work. Okay, step 1, solve for x. Step 2, switch x and y. That's what we're going to do. The first part, take a few steps, but that's okay. That's okay. So first I'm going to say, how do I get rid of that natural log? By saying e to the power of that equals e to the power of this. So e to the y equals e to the natural log of something. Those are inverse operations. Just like up here, natural log got rid of the e to the something. Here, e to the something is going to get rid of natural log. So it's just going to leave negative 3x plus 7. Okay, hopefully that made sense. E and natural log cancel out. Now I'm going to subtract 7 from both sides. I'm trying to get the x by itself here. E to the y minus 7. The minus 7 is not part of the exponent. Okay, I need to get rid of multiplying by negative 3, so I'm going to divide by negative 3. And negative 3 divided by negative 3 is 1, so that's 1 times x, or you could just say that's x. And write this all out, e to the y minus 7 over negative 3. So really that's all we could do there, I guess. E to the y minus 7 over negative 3. Didn't really do anything there. Just wrote it again. Okay, what's the last step? Don't forget the last step. Switch the x and the y in the equation. So we're going to say y equals e to the what? The x. Switch the y to an x. And that's it. A little bit tricky, a little bit annoying, but there we go. This one, we do the same thing. First, we're going to isolate the natural log before we try to e to the power stuff. So add 1 to both sides, you get y plus 1 equals natural log of x plus 3. Then to get rid of the natural log, we're going to do what we did on the other side. E to the power of that stuff equals e to the power of this stuff. And that will cancel, and we're undo it, the natural log, and leave us with an x plus 3. This side will have e to the y plus 1. Okay, how do we get x by itself? What are we going to do next? Very simple, just subtract 3 from both sides. So we have e to the y plus 1 power minus 3 equals x. Oh, sorry about that. And that's it, except we've got to do step 2, switch x and y. So the x becomes y, the y becomes x. There we go. If you want to write it as y equals e to the x plus 1 minus 3, that's great. Same thing over here, or you could say y equals y equals e to the x minus 7 over negative 3. Okay. Number 11, properties of logs. Hopefully, you had your flip chart with all the log rules. Log of a times b, or log of something times something else, equals log of the first factor plus log of the second factor. Log of something divided by something equals log of the numerator minus log of the denominator, and log of something to a power equals the power times log of that thing without any exponent on it, or with an exponent of 1 technically. That's the only 3 properties you've got to use. And on the expand questions, 11, 12, 13, you got to make stuff like this look like that. Stuff that looks like this look like that. Stuff that looks like this look like that. So breaking it apart, expanding it, making one log become 2 logs, making stuff in the logs go outside the logs. On the next page, it says condense, which means go backwards. Take this, make it that. Take subtraction, make it look like this. Take this, look like. Okay, anyway, let's just go. Okay, power of stuff. The power will go there. That's the power property. This guy right here. Okay. Then this log can become 2 logs because this times that, so log of this plus log of that. And remember, the 6 is times this log, which became that log plus that log, so it's 6 times, sorry. Okay. 6 times this, and this became that whole thing, so it's 6 times this whole thing, where I got the big bracket parentheses there. Power property, again, like we did with the 6 at the beginning, we're going to do it just with this log, and it's going to become 3 log base 8 of x plus log of the log base 8 of y. And now we got to use distributive property, basic algebra stuff. 6 times that plus 6 times that. 6 times 3 is 18. So we got 18 log base 8 of x plus 6 log base 8 of y. Bam. There is number 11. So we used, in that one, this property and this property. Okay, this one, we're going to use these 2 properties. So maybe if you missed number 12, see if you can figure it out for a second before I do it here on the video. Okay. We got log base 6 of something divided by something. So the division is going to become subtraction when we separate it into 2 logs, or expand it. So it's going to be log base 6 of x to the 4th minus log base 6 of y to the 6. And then power property is going to do that, make it 4 log base 6 of x minus 6 from that 6 in the right there, log base 6 of y. And that's it. That's only 2 steps, basically. Okay, number 13. Going to use those same 2 properties. The 5 we'll deal with first, so it'll become 5 log, oh, it's base 6 again, of u to the 4th over v. Then that's going to be 5 times okay, so hopefully that makes sense. The quotient property, this guy right here, quotient becomes subtraction. Then, similar to the last couple steps on number 11 here, 4 log base 6 of u minus log base 6 of v, and distribute the 5. 5 times 4 log base 6 of u is 20 log base 6 of u. 5 times log base 6 of v is 5 log base 6 of v. Okay. Hopefully that all makes sense. Good, good, good. Let's continue. Last 4 problems. Number 14 and 15 are going backwards of what we were doing on the last 3 problems. So we're wanting to use those same properties but go backward, going backwards. So what would make a 4 or a 2 go in front of the log if it was a power? So this is going to become log base 9 of a to the 4th. So condensing, we're trying to put everything together inside one big log. Instead of separating it out, combining stuff together. So log base 9 of b squared. That's the product property. This guy right here. But instead of putting the 2 to the front, we're taking the 2 from the front and putting it inside as a power. Okay. Then adding 2 logs of the same base will become multiplication on the inside of the log product property. So a to the 4th times b squared. Oh, that's just supposed to be a 9 right there. Okay, that is it. It's all inside one big log. Okay, now number 15, similar for the first step. I'm going to use the power property going kind of in reverse. So that's going to become x to the 3rd. And this is going to become y to the 9th on the inside of this log here. And since there's no base written, we should assume it's 10, I believe. So since there's no base written up here, you don't need to write it down here. It's assumed it's 10 if there's none written. Okay, subtraction. Addition, use the product property, make it multiplication inside a big log, one log. This one, you're right, we're going to use the quotient property. So it's going to be log secretly base 10 of x cubed over y to the 9th. Everything's on the inside of the log. There's just one big log. That's a 9. We're totally condensed. There's those two. Last two problems. Okay, this one is pretty easy. Pretty easy if you have an idea what's going on. Even if you don't know what's going on or what a log is, you could kind of reason to yourself, if the log base 4 of that stuff equals log base 4 of this stuff, then that stuff must equal this stuff. You might want to rewind and replay that for a second and think about it. If that is a little confusing. But if you do know how logs work, you say the inverse of a log of something, base 4, would be 4 to the power of that, of it. So 4 to the power of something, 4 to the log base 4, it's kind of like square root of x squared, or times 4 divided by 4. Something like that. It's the inverse operation. So we're just going to end up being left with 7 minus n equals 10 minus 2n. All that stuff to say. Except, technically, we're going to have to go back and check our answer at the end and make sure that whatever we get for n, 7 minus n is greater than 0, and 10 minus 2n is greater than 0. Because remember, you can't take a log of a negative number. So technically, we need to check our answer and make sure that the stuff in the logs at the beginning wasn't negative. But it's not going to be. So, but I'll mention that at the end when we get there. So now we got to solve for n. Pretty easy. We got to combine all the n's. That's the first. Let's add 2n to both sides. And that's negative 1n, in case you're getting a little confused here. Negative 1n plus 2n is positive 1n. And negative 2n plus 2n is 0. Okay, I'm going to, which you don't need to write plus 0. I'm going to subtract 7 so that the only thing that's left here is 1n, or I could just say, okay, let me write this in 2 steps just to be thorough here. 0 plus 1n equals 10 minus 7 is 3, so n equals 3. And to check that, these 10 minus 2 times 3, is that positive? Yes. 7 minus 3, is that positive? Yes. So nothing wrong with 3 as the answer, so that's good. Okay, number 17. Okay, to get rid of log base 6, we've got to do 6 to the power of it. But there's 2 logs being added together here, so we don't want a whole bunch of junk here when we do 6 to the power. We want 1 log base 6, or else weird, crazy things are going to happen. So we've got to use the log properties that we just talked about on like a page ago. Actually, even just right up here on the same page. And we're going to say log base 6 of 2 plus log base 6 of x minus 1, we can combine into one big log base 6. And that's going to be 2 times x minus 1. Okay, log of one thing plus log of another thing, you got the same base. We'll multiply those things inside a single log. So just for the heck of it, 2 times x minus 1 is 2x minus 2. Okay, now we're going to go 6 to the power of this stuff equals 6 to the power of that. Okay, don't try to do that at the very beginning. That will mess things up. You can ask me to explain why exactly it would mess things up in class if you want more explanation there. But anyway, 6 squared is 36, not 12. 6 to the power of log base 6 of something, we'll just leave the something. So 2x minus 2 equals 36. Now it's pretty straightforward to solve for x. We're just going to add 2 to both sides. 2x equals 38. You could say 2x plus 0 if you want. Okay, to get rid of multiplying by 2, divide by 2. X equals 38 divided by 2 would be 15 plus 4, 19. That's a 2. Sloppy 2. Thanks for doing your test corrections. Be sure to turn them in by Friday, before the end of the term. Have a nice day.